Hi everyone. Yesterday I solved this problem, mean costs, find mean cost to connect connect all points. I have solved it by using by implementing Kruskal's minimum spanning tree algorithm. Then I started to I watched solutions of other users. I took a look and I realized that most of the solutions used Prim's algorithm. So today I'm going to solve this this problem again, but with different approach with Prim's algorithm. So what is Prim's algorithm? I took a look on this article, but I didn't study it. I didn't read it accurately. So I will read it right now. So we have now we know how Kruskal's algorithm works. Like Kruskal's algorithm, Prim's algorithm is also a greedy algorithm. This algorithm always starts with a single node and moves through several adjacent nodes in order to explore all of the connected edges along the way. So Kruskal's algorithm traversed the creates the edges, all of the edges, then it sorted it in non-decreasing order. Then it go through this list of given edges and add it to a graph until it gets n-1 edges, and it checks on every step if the current edge creates a cycle in the graph. If it creates the cycle, if the edge would create this cycle, then algorithm skips that edge and go to the next edge. But here Prim's algorithm looks like it works by points, by verticals. The algorithm starts with an empty spanning tree. The idea is maintain two sets of verticals. The first set contains the verticals already included in MST, and the other set contains the verticals not yet included. At every step, it considers all the edges that connect the two sets and picks. It considers all the edges that connect the two sets and it works with edges and picks the minimum weight edge from these edges. After picking the edge, it moves the other endpoint of the edge to the set containing MST, minimum spanning tree. A group of edges that connects to sets of verticals in a graph is called cut in graph theory. What is cut? Aha, I see. It is a cut. Cut is a minimum of this if the size or weight of the cut is not larger than the size of is not larger than the size of any other cut. The illustration shows a minimum cut. The size of this cut is 2. And there is no cut of size 1 because the graph is bridgeless. Partition, cut is a partition of the verticals of a graph into two disjoint subsets. Disjoint subset. I see, so we cannot we can split it. What is the maximum cut? Size of the cut is equal to 5. 1, 2, 3, 4, 5. 1, 2. Okay. A group of edges that connects two sets of verticals in a graph is called cut in graph theory. I see. So at every step of Prim's algorithm, find a cut, pick the minimum weight edge from the cut and include this vertex to the in MST set, the set that contains already included verticals. How does it work? Determine an arbitrary vertex as the starting vertex. Follow steps 3 to 5 till there are verticals that are not included in the MST. Till there are verticals that are not included in the MST. Find edges connecting any tree vertex with the fringe verticals. Oh, sorry, I was stuck. Find edges. I am writing video. Okay, follow steps 3 to 5 until there are verticals that are not included. I don't understand what it is. Okay, Let's try to find out it later. Find step 3. Find edges connecting any three vertex with the fringe of verticals. I need translation. Fringe verticals. Okay, and what it is? Let's translate all of it. Let's until I need to read 3 to 5 steps before. Find edges connecting any three vertex with the fringe verticals. Okay, find the minimum among these edges. Then add the chosen edge to the MST if it doesn't form any cycle. Then again, follow steps 3 to 5 till there are verticals that are not included. Until there are, not there not. Until there are verticals that are not included in the MST. I see. Well, when we add all the verticals to the MST, then we finish. And then we consider that we finish. And then in the end return the MST and exit. For determining a cycle, we can divide the verticals into two sets. One set contains the verticals included in MST, and the other contains the fringe verticals. Illustration. So we have following graph. Firstly, we select an arbitrary vertex that acts. What means arbitrary? Arbitrary, random. Here we have selected vertex 0 as the starting vertex. Okay. Step 2. All the edges connecting the incomplete MST and other verticals are the edges 0, 1 and 0, 7. Between these two edges with minimum weight is 0, 1. So we include the edge and vertex 1 in the MST. Then we have 0, 1, 0, 1. And then, we included 0, 1. Then we have 0, 1. The edges connecting to the incomplete MST to other verticals are 0, 7, 1, 7, and 1, 2. Yes. Among these three verticals, the minimum weight is 8, which is of the edges 0, 7 and 1, 2. Let us here include the edge 0, 7 and the vertex 7 in the MST. Okay. We could have also included edge 1, 2. Yeah, so it doesn't matter which one of it. Then we have 1, 7, 1, 2, 1, 7, 6, 7, 8. Why we don't have 1, 2, 7, 6, and 7, 8? Also we have 1, 7. We remove it because 1, 7 is creates the cycle. So of these three edges, 7, 6 is the shortest edge, and we include the 6. And that's how we can add every other. Then we add 8. After it we will add 3, then 4. So that's how we have this minimum weighted edge. Let's see. If we connect it like that, weight is 9. No, not the 9. Let's compare. Is it the same or different structures? 4, 8, 12, 13, 15, 19, 21, 28, 37. 37 and 4, 8, 12, 14, 15, 17, 21, 28. The same, 37. Interesting. Then follow the given step. How to implement it? Okay. We create a set that keeps track of verticals already included in MST. Okay, assign a key value to all verticals in the input graph. Initialize all key values as infinite. Assign the key value as 0 for the first vertex so that it is picked first. I see. While MST set doesn't include all verticals, do next we in the loop. Pick a vertex U that is not there in MST set and has a minimum key value. Include it. Update key value of all adjacent verticals of U. To update the key values, iterate through all adjacent verticals. And we iterate it for every adjacent vertex V. If the weight of edge UV is less than the previous key value of V, update the key value as the weight of UV. The idea of using key values is to pick the minimum weight edge from the cut. Below is the implementation of the approach. Not a big. So we have graph. Why the graph is so big, guys? It is not the same graph. Also we have another approach, OV squared, if they representing. Okay. other users solved it using priority queue. But I will solve this way. Optimized approach of Prim's algorithm. We transform adjacency matrix. Then we create pair to store the vertex and its weight. We sort the list on the basis of lowest weight. Transform. Oh my god, no. I need to watch the code because I don't understand. Example usage. We have a graph, spanning tree, with priority queue. I see. What else? Nothing else. Let's try to implement first approach. So we have number of verticals in the graph. Yes, it is the points amount for our case. Utility function to find the vertex with minimum key value from the set of verticals not yet included in MST. Min key. I see. Print MST. I don't need it. And Prim MST. I need to try to understand how it works. So we have parents, constructed MST. We have key. Okay, and the MST set itself. We initialize all keys as infinite. An interesting number max value. Then we set the first vertical as 0. Parent is -1. Y is -1. I don't understand. -1 means that it is the root. It doesn't have why it is not the parent of itself. Okay, and then we go through all of the points in our keys. Let's just copy it and try to adjust to my code. Sorry. Why there is trailing spaces? I don't need to write it to browser. don't care anyway. So we have points array. We give it to print Prim MST. The graph is the, let's say it's graph, okay. Parent key, we MST set key, okay. Graph glance, okay. Or no, or yes, graph length is, yes, not graph, let's write it points. So we initialized all the values, then we assume that the first point has first vertex. We give it zero to its key because to start from it. Okay. Let count points length -1. We go through all the points, try to find mean key for each of it. I need to pass the points to mean key method. To iterate through them. Key v return mean index. What means mean index? I don't know, but we have it should work somehow. I don't need to print anything. So that's it. We go through all the points, add it to result, then we update key value and parent index of the adjacent verticals. Points. If and here is the can be I can have problem if points uv what have we done, what we have in the graph array of arrays. I have array of arrays. It looks like I have here 2 points. It is in the edges, so I need to build up the edges anyway, if it is the edges. Graph UV. What is UV? V is U count. We go through all of the items of the graph, all of the verticals. Okay. Then we pick the minimum vertical, then we add it to the result, then we update key value and parent index of the adjacent verticals. Graph UV is non-zero only for adjacent verticals. Why it is non-zero? Graph UV. It is the graph representation of the graph where we have number if no or yes. Just where I see the indices of the array is the point, it is the vertical says first index, and the indices in the inner array is the points of for outer items. Yes or no? For example, index of this item is 0, 1, and 0.01 has connection with the graph UV is smaller than key V. 2 is the weight of the point, which is the weight of the 0, 1 array, the 0, 1 edge which connects points 0 and 1. So I need to, if I want to use this algorithm, I need to prepare my points to edges array like this. How can I do it? I have the points array, and then I don't want to create the array which will be the size of, how is constraints, what is 1000, length of 1000 and array of 1000 lengths in each of them. I can't avoid it because our points, I need to check each of the I see, I need to check each of the edge. So I need to create edges, and I need to pass edges. It will be edges and points. And here I will check edges, edges, edges. Points, points, points. Okay, create edges. How can I create edges from points? Function create. So I go through each -1, I increase I, then for var j 0, j less than points length, increase j by 1. Also not j but start I plus 1. And what we do, I have the var edges is empty, and I return edges. Now I need to push to the edges each of the points. How can I push it? How can I push it in the form with like that? So the index of outer item is it is array of array. Length of the array, it is the points length or no? So we have 5 points by 5. Yes. And fill them with zeros. Oh my god. New array points length, fill new array points length, fill 0, something like that. Then we just fill edges I, j, and here we calculate distance. The distance is math abs points points is it coordinates? Yes, points I 0 minus points J 0 plus ABS points I 1 minus points J J1. Am I right? Looks right. I am right. Prim MST. Why Prim MST do not return anything? I don't need ranks, and I need to pass edges and points. Parent key. Aha. Print the constructed MST. Edge weight BR. How can I calculate the aha? I am calculating it here. Let me add some braces here, because parent U key edge and edges UV. I need just result var cost is 0, and then I cost plus 1 this number. Yes, and return Prim MST. Get I need the function get distance. Or I don't need it. I don't want to create it now. I just need to find the distance between the first and second point here. Let's try it. Oh, it doesn't fail, but I didn't return mean cost. It didn't fail, it works, but the answer is wrong. I added extra number, but it was it gives right number. Well, let's try to understand where is the where is the error? First of all, let's try to print our edges. Is there? They are wrong. Why? I don't know why. IJ points I points J points I points J. I calculate distance between ith and jth point. Yes. Why the distances is the same? I don't understand. So let's try to understand it in the lesser example. So we have 312 minus 25 minus 41. The distance between zeros is 0. Okay. The distance between zeros point and first point would be here. The distance between first and 0 should be here. Oh, I probably understand it's wrong. No. This one is equal with 0, 2, 0, 6, 0. Then 2, 0, 3, 8, 5. 2, 0, 3, 8, 5. Yes. I should get the same result but I didn't, or I did. No, it should be 4, 9, 10, 4. Something wrong with my indices. So I don't need to avoid repetitions, something like that. Seven, 14, no. It's closer, but when I get to when I is the 1 and the J is the 0. I is the 1, J is the 0. 7, 7, okay, but when it is 2 and 2. 2 and 2. The distance between on the diagonal should be 0, 0, 0. Yes, why it is not the 0? Yes, here should be 0. Let's try to find it out. distance between edges ij 0, 0 should be zeros point. We get zeros point. Yes. Then we get a zeros point again. Takes first item from it, so 3 minus 3 is 0, and here the same, should be the same. Did I pass the points? Yes. I have the error. Pooh. Where is my error? Let's I J points length edges ij points I points j points I points j. Let's try to print edges each time for each iteration. What we will get? First time is 0. Oh, wow. It fill it. Aha. Guys, I understand. This new array is the same for each row. It is the same array. So I need to, how can I do it? I can do the map, something like that, and now it should work correctly. Also, I need to wrap it to, no, why it doesn't work? Let's print what we got. Five empty items, but I don't need to get empty items. Is it the same? Am I yes. Map doesn't work. So we have a map and I return new array. Let me return it. Fill like this. Map Why are you empty? Maybe like that. Still empty. Maybe for each can help me. I can't return result, but I can write it edges index result. What am I doing wrong, guys? I don't understand. Let's console log result. I see. So this is the case when it doesn't iterate through empty items. Let's try it like that. For example, fill 0, then map fill 0. It works. We have correct. I have correct array, but it's now something else wrong. Let's try to find it out. So I have edges. I go through the edges. I have graph, if graph UV and set to false, and graph UV less than kiwi, parent VU, kiwi. So we use graph only 3 times. Edges, 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 edges. After it, let's console log console log key. Update key value at parent of the pick. Consider only those verticals which are not yet included in MST. We picked the minimum key vertex. I see. Probably I need to fill I need to calculate mean cost while I find mean key. I find mean key and I know it's mean index of V which is closest to mean key. Let count 0. How can I use count? Key MST set points. If MST set false and key V less than min, until we didn't get it and its value less than max, then we get it and add it to MST set. Probably I need to calculate a result from key array. Parent and key. Expected 20. Is it the 20? 4 and 9, 13. 16, 20. Yes. I need to calculate the key array but I did the same thing. I make extra calculation, extra additions to mean cost while we check something here. While updating key values. Sorry, I see. So I need to return some. Do we have math sum in JavaScript? Math sum. I know that we have min and max, but sum, no, we don't. Okay, I will calculate it by myself. Key reduce as well and here is the result. Yeah, it is accepted. I remove removed cancel logs. Also, I want to remove comments, but no, I will not remove comments. Let them stay here. Wow, this solution is much more performant than my yesterday's solution. Interesting. Where is the estimations? Blah blah blah. Time complexity OV squared. If the input graph is represented using adjacency list. If it represented using adjacency list, then time complexity can be reduced to OE multiplied by logarithm V. Auxiliary space OV. But it's not represented using adjacency list. Adjacency matrix. Adjacency will have all nodes which are connected neighbor. No, it's not adjacency list. Time complexity, auxiliary space. I don't get it. Okay, let's, as I understand, the time complexity is OV squared and the space OV. Let's watch about Craphs algorithm. It is OE logarithm E. It is the edges amount, which is more or less. Let's assume, yeah, it's more than verticals amount, verticals squared, probably, because the verticals amount is less than the edges, all the edges amount. If we have 4 verticals, then we have 1, 2, 3, 4, 8 edges. So the 8 by logarithm 8, and even more for more numbers, I see. So Craphs algorithm is less performant. Also we sorting it. Overall is even more. I like to learn new techniques, especially when you beat a lot of users, so much users. Super. I am satisfied by this approach. Also, I'm tired. Thanks everyone who watched it, and bye.